Hey guys, and welcome back to another tricky A-Level Maths exam question. Now here today, we're going to look at a geometric series proof. So it's the proof of the sum of the first n terms. So this is always a 4 marker if it comes up. Now it's not come up on the new spec yet, and I'm not sure if it will, in the next couple of papers, but it's worth knowing. It's not too tricky of a proof. In terms of memorising anyway, it's not too long. It's one that a lot of students do forget. So let's have a look at doing it. So what we've got to consider is forming two sequences. So the first one is told to us here. A geometric series is A plus AR plus AR squared. Now that's just how a general geometric series will work. So let's write that down as Sn. So sum of the first n terms. Like it says here, it's going to be A plus AR. And it's going to carry on, right? This is going to carry on all the way plus up to the nth term. So it's going to be all the way up to plus AR to the n minus 1. So that's our nth term, right? So that's where the sequence will finish. What we need to consider now is forming the next sequence, or the series. So the next series is if we're going to take this series again, but we're going to times it by the common ratio. So that would be R Sn. So we get this series going. So all you got to do is times each term in this series by R. So the first term won't be A, it will be AR. So we times it by R. So that's AR. Next one won't be AR, it'll be AR squared, because we're timing it by R again. So plus AR squared. Plus AR squared. And plus, and this is going to carry on again all the way up till, so the very last term, but I'm going to put this one just before it, so it's going to be, we'll have an AR to the n minus 1. Again, and then our very last term, if you were to add 1 to the power here, you'd get AR to the n. So AR to the n. So that's our last term. Now what we need to do is consider if we were to take away this series, RSN, from this series, what would we get? So what you actually notice that is a lot of the terms will cancel. If you see here now, we've got AR here. So them two will cancel. We've got the next one would be an AR squared, so if we were to cancel that, that would cancel with that. And this would carry on forever. So all the middle terms that we don't bother writing down because it just goes on for a long time, they would all cancel. So you don't need to express that. It's just implied by when you cancel the next few terms. This AR to the n minus 1 would just cancel with this one. And all we're going to get left with would be the minus of this because you're subtracting it off. So what we've been left with now is Sn minus RSn. Sn minus RSn. Well, that's going to be equal to A, what we've been left with, minus this other term that we've been left with. Now, because we're subtracting it, this changes from positive to negative. That's minus A R to the n. Now, this isn't quite in the form that we needed, but we're not too far off. We've just got to do a couple of extra steps. Can we do anything from here? So have a look at what we've got now. Can you spot what we're going to do? So what we're going to do from here is factorise both on the left-hand side and the right-hand side. So what can I factorise on the left hand side? Well, that's going to be the Sn. It's in both this part and this part. So I'm going to factor out Sn. So that's going to give me 1. So this times by 1 minus R. Well, this looks pretty good. We've got a 1 minus R here. And we've got this here. So this is looking pretty good so far. What can we factor out from this side? Well, I've got an A minus AR to the n. So I can factor out an A. So that's going to look like that. Again, what am I going to place? It's going to be 1 minus R to the n, like so. So that's my factorised side on here. Now, all we've got to do is get into this final bit. So I've got Sn times 1 minus R is equal to A times 1 minus R to the n. And notice we've got this side here, A times 1 minus R to the n. It's already the numerator. So last step, if you can spot it, we're just going to divide through by the 1 minus R on this left-hand side to us Sn. So the sum of the first n terms is equal to A times 1 minus R to the n divided by 1 minus R. And there we have it, guys. So that's the full proof done for all 4 marks.